sound, I mean, it's kind of hard to know, but does that sound about right? Yes. Okay. And so that is obviously a fairly small number, 0.099. And so the instructions say write your answer in scientific notation. That's what we're going to do. Let's talk about what scientific notation is, like the proper form. With scientific notation, the number has to be between 1 and 10, not including 10. It's got to be between 1 and 10, not including 10. So 0.099, is that is that in between 1 and 10? I don't think so, right? Because 0.099 is definitely smaller than 1. So what I'm going to need to do here is I'm going to need to move my decimal a little bit. So I need to take the decimal from where it is, and I need to move it one spot to the right. So that would give me 0.99, right? Is that within that range of between 1 and 10? No. It's not. So let's move it again, one spot to the right. So now it's 9.9, right? That is between 1 and 10, not including 10, right? Okay, so then I know in scientific notation this number is going to be 9.9, but then I have to put a 10 power on the end of it. That's how I basically adjust for the fact that I just moved the decimal. So times 10, and this is where, and we got to put an exponent up here, times 10 to the something. It is the negative second. I'll go ahead and put that in there. This is where sometimes there's some confusing moments where people will say, well, if you move the decimal point this way, do this with the exponent, move the decimal point that way, you do this with the exponent. And there are definitely some rules to be had there, for sure. I'm not a fan of that because in my years of experience, I've seen people like flip those around so many times. It's almost like, man, doing those rules doesn't make a lot of sense for a lot of folks. If you got them solid, of course, you do that. But for folks that are, maybe not as solid, here's the way I would present it. This number to begin with, the number we started with up here, oh boy, that's a little bit too much. The number we started with up there, was it small or was it large? Therefore, when you go to scientific notation, your exponent on your 10 power should go down. Should be a negative. So negative exponent on the 10 power means small number. Positive exponent on the 10 power means you have a large number. So let's transition to number 2. How many atoms are in a drop of water? You guys know an atom is a really tiny unit, right? Of course, there's protons and neutrons and electrons, things like that are smaller, but atoms are very small. So that is a very, very large number, isn't it? Probably. I don't know what it is. It's basically a 167 with 19 zeros after it. 19 zeros, yeah. Okay, so currently the decimal point is not written, but where is it?
You want to do 1.67?
Well, but no, where is it right now? Far right. Yeah, so it's all the way over here. Oops, let's try that again. So yeah, decimal point is all the way over here. And so I've got to move it to the right or to the left to get this number between 1 and 10. Which way? Got to move it to the left. So since it's such a large number, I'm just going to go in groups of 3. So there's 3, 6, 9, 12, 15, 18, 21 places I had to move it. So now my number is between 1 and 10. It's 1.67. So 1.67. And then, as mentioned, we've got to include the 10 power. And so instead of saying I move the decimal to the left so the exponent does this or that, I just look at it like, man, that was a gigantic number. So therefore my 10 power needs to go up, right? It needs to go up 21 places. So 1.67 times 10 to the 21st, and that being a positive 21, would be how we'd write this in scientific notation. Well, any questions about that? Okay, awesome. Well, let's practice going the other way. If you notice, this next section says write the number in standard form. Take a minute and write down numbers 3 and 4. You'll see there, and we'll work on those here in just a second.
Should we do them?
So can you guys see that numbers 3 and 4 are in scientific notation right now? Like the number 1.76 and the number 3.1, they're both between 1 and 10, not including 10. You got the 10 powers. Hopefully they look like scientific notation for what you've seen before and what we just did. So these are in scientific notation. We want to go back to like the normal form. It's called standard. So take a look at number 3. 1.76 times 10 to the 5th. Again, the whole direction, right and left, positive exponent, negative exponent, I don't get too hung up on. I do look at the exponent, though. 10 to the 5th. It's a positive number, right? 5, positive number. So since that number is positive, is this number that we're dealing with in standard form, is it going to end up being really large or really small? It's going to be large, right? Big, large, very large, kind of matter of opinion, but it's going to be large for sure. So 1.76 times 10 to the fifth, what we're going to do is we're going to start with that. And then in order to make this a large number, which it is, I need to move the decimal which direction? Right. To the right. Yep, so we're going to go 1, 2, 3, 4, 5 places. That 5 places should match the exponent of 5. I got a little issue though. There's all these blank spots. What do I put in those blank spots? I do put zeros. Yep, so put a 0 here, here, and here. So my final answer would be 176,000, also known as 176,000. What do you think? Is this system working for you, or whatever system you're working with? Okay. And we got this other one, number 4, 3.1 times 10 to the negative 9th. This time the exponent is not positive. It is negative. So that tells us that this number really is pretty small. Yeah, pretty small. So I start off with 3.1. Actually, give myself a little more room here. 3.1. And that negative 9, if I'm gonna make this the small number that it is, I need to move the decimal which direction? To the left. Yep, 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a lot of blank spots. So we got to put zeros in all those. So there's 1, 2, 3, 4, 5, 6, 7. There are 8 zeros. The decimal goes right there. So putting this in standard form, I would get 0.8 zeros. There's 4 of them, 5, 6, 7, 8, and then a 3, 1. Obviously a pretty small number by any stretch. Okay, what do you guys think? Numbers 1 through 4 were about can you get into scientific notation, and then can you get out of scientific notation back into standard form, standard notation. So do you guys have any questions? Does all feel familiar to you?
Yeah.
Have you ever used your calculators with scientific notation?
Yeah, definitely.
If you haven't, get a chance right here. So take a look at number 5. Please write down number 5. I'm going to switch screens on you here in just a second. 5.7 times 10 to the third times 2.2 times 10 to the negative 6. There's a lot of ways to do this. You certainly could do these by hand, but I'm going to show you how to use your calculator, hopefully as efficiently as possible. So if you do have your calculator, please do get that out right now. So anyway, so we're doing this 5.7 times 10 to the third times 2.2 times 10 to the negative 6th. And I want to show you guys how you can use your calculators to make this super efficient. So look on your calculators really carefully. You also can see the 7, right? What's right above the 7?
The 7. Oh.
A comma. And then look on the blue menu above the comma. What do you see?
Scientific.
No, it says EE, right? EE. So what EE stands for, it stands for literally just this. Times 10 to the something. So here's how we would enter this into our calculator. We're going to go 5.7, just like you'd normally enter it. Nothing new there. But instead of writing like times, 10, exponent, whatever, all we have to do is we just go blue EE. So it shows up as 5.7E. The way you'd read that is you'd say 5.7 times 10 to the, and we got to tell the calculator what the exponent is. And so our exponent is a 3. So 5.7 times 10 to the 3. At this point, I've got that number entered in. I'm supposed to multiply that, as you saw in the example, multiply that times 2.2 times 10 to the negative 6th. So 2.2. And how do I get the times 10 to the? EE. Yeah, so it'd be second E. And it has to specifically be that button. I messed up. Let me go back. I forgot my times. Oops. So I'll start over. Let's go 5.7 times 10 to the 3 times 2.2 times 10 to the negative 6th. Make sure you're using the negative button instead of the minus button, of course. I'm sure you guys are used to that. Any questions on that setup? Notice I never put times 10 to the anywhere, right? E is what that means. So please don't put an extra 10 or an extra to the or anything like that. Just put E, that means times 10 to the. Okay, so at this point, of course, we just hit enter, and it comes back with this 0.01254. Okay, so we could have done that by hand and been at least somewhat successful. Would have taken us much longer. Obviously, the calculator does it faster. That's kind of the point. So 0.01254. Let's write that down and talk about what we could do with it. We're gonna manipulate it just a little bit. So here's what it told us. Actually, I'm going with this. It told us equals 0.01254. Is that right? Perfectly good answer. That's written in a certain form. Is that written in standard form or scientific notation? Standard form, right? Because that number is not between 1 and 10. So let's just for practice here, let's do this again. Let's try to write this in scientific notation. Let's put this number between 1 and 10 and put the 10 power on it. So we need to move the decimal, obviously. Which direction do we need to move it? To the right, how many places? 2. Yep, so we're going to go 1, 2 places to the right. That gives us 1.254. Now we got to put that 10 power on there because we moved the decimal.
It's a small number.
That's the question. Is it going to be a -2 or +2? Since it was a small number, it's a negative exponent. So times 10 to the -2 would be our 10 power there. Okay, what do you think? Calculator, pretty powerful tool here, right? Okay, cool. So let's do this. Let's try this next one. Can we? Can I show you that later? I would like to approach this from the perspective of you'll have your calculator with you. But I'd be happy to show you how to do that too. We got time for maybe one or two more at the most. So get your calculators back out and let's try number 6. Number 6 is 6.5 times 10 to the -7th over 1.3 times 10 to the -3rd. A very similar problem to what we just did, except it's division instead of a multiplication problem.
My answer came in scientific notation.
Yeah, sometimes your calculator will do that. You know, you can actually force your calculator to answer everything in scientific notation. If you go back to mode, you can put it in scientific notation mode. So even if you put like 5 plus 50, it'll come back with like 5.5 times 10 to the 1st instead of 55. You can make it do that if you want. You don't have to, obviously. Your calculator will definitely be a powerful ally for you here with these scientific notation exercises. And I'll tell you this for sure, whatever science courses you take over the next 3-4 years, your science teachers and you will appreciate the fact that you have worked on this already and you kind of understand what scientific notation is. They're going to kind of come from the perspective that you already know it. Yeah?
Wait, why would you use this in science?
So science with measurements can be like really large or really tiny. And that's unfortunately like in a chemistry class or a physics class, it's very rare that the answer just comes out to be 7. It's usually like, 0.000074. And so scientific notation is just easier to handle. And then sig figs. And of course, scientific notation should tell you the number of sig figs.
Yeah.
It's very handy that way. So yeah, it's a useful tool for sure. Do you guys do this on the calculator?
Mm-hmm.
Allie, what'd you get?
I got 5 times 10 to the power of -4.
5 times 10 to the -4. Did you guys get the same thing? That makes sense. Yeah, the 5. Yeah, I agree. So I'll tell you what, Davis. You had asked, how would you do this without a calculator? It's not too bad. Well, let's try this one real quick. So you've got to just do the division by hand. And so if you're going to do this without a calculator, the division by hand with the 10 powers is actually quite easy. We've done this sort of thing before. I've got 10 to the negative 7 over 10 to the negative 3. Those are like bases, aren't they?
Yes.
So what do you do when you're dividing like bases? You subtract, right? So the rule still applies. We could do some flipping if we wanted to, but the rule still works. So it would be times 10 to the negative 7 minus negative 3. Well, no, it's actually ends up being plus 3, right? So it'd be negative 4, yeah. So you can see how that's going to agree. But then, honestly, Davis, the 6.5 and the 13, you're going to just have to do like some long division or some other type of a division to be able to do that. So you just say, 6.5 divided by 1.3. Maybe you move the decimal over. It's 13 into 65. It ends up being 5, but, with no remainder, thankfully. So you're going to have to do some kind of a long division or a long multiplication if it's a multiplication problem. Thankfully, the 10 powers are very easy, but the other numbers potentially not easy at all. So that's why I suggest the calculator, because if you're dealing with scientific notation, the calculator is probably right there. Okay, let's finish up with number 7. This is 3 times 10 to the negative 9th. Those parentheses are very important. So when you're working on this in your calculator, I would suggest you use those parentheses as well, because that whole thing is to the 5th power. All right, so we're about up against our time. So I'll do this on the calculator just for one last calculator problem. See if we all agree on our answers. Here we go. So I would open up with parentheses. I would just put parentheses 3. And then I'd use that E like we did before. And then, so that means times 10 to the negative 9th. Close my parentheses, so this just should look exactly the way that it's written. And then to the 5th power. Does that entry make sense to you guys?
Wait, how did you put the 5th?
I used this little caret over here on the right.
Yeah.
Sorry, actually the arrow's not showing up. So it's right above the division symbol. Right underneath clear. So 3 times 10 to the negative 9th to the 5th. So then, of course, you just hit enter at that point. And it is a tiny number. You guys agree with that? 2.43 times 10 to the negative 43rd. That would be decimal point. 42 zeros. And then a 243. That's obviously a pretty tiny number. Okay, we'll finish this stuff up tomorrow. Hope you have a great day.